Hi there. In this section, we're going to look at a preview of graphs. There are different types of graphs. Of course, there's a circle graph, line graphs, multiple line graphs, bar graphs, and stack plots. Those are the types of graphs that you'll see here in the next couple of sections. I won't go through every single one of these examples like always, but I will hit on a couple of them. So here on the front page, I'm going to look here at example 1 with the circle graph. And in part A, this is looking at the foreign languages studied, and so you can see the graph over here on the left. Part A says, well, what language do most people what language do most people choose to study, excuse me. And so we can see here that our highest percentage here is this 55% corresponding to the language Spanish. So we would put our answer there. And then it says in part B, what percent of the people choose to study German? So German is this light aqua color here, which would represent here 5%. Now for the last two parts of this question, it says suppose 2,500 people participated in this particular poll. Part C then wants to know how many of those participants would have chosen to study French. This is where then we want to utilize one of our formulas from the last section, or the last unit. Part equals percent times whole. And we know the percent that chose to study French is 30%. So we put that in as a decimal. The 2,500 people that have participated in the survey, that represents not part of the people, that represents the whole. And we're trying to figure out what part then would actually have chosen. Of those 2,500 people, 30% chose French. We want to figure out now, well, what is 30% of 2,500? When we do this multiplication, we land at 750 people. Okay. Part D would be done the exact same way, so I encourage you maybe to pause the video here, make sure that you can do part D without any problem. And also I would go ahead and say maybe you also want to at the same time go ahead and do example 2 and check yourself by the solution key, and then I'm going to pick up on the next page with example 3. So down here in example 3, you have a multiple line graph. And usually with a multiple line graph, it just gives you the opportunity to compare multiple items all in one place, okay, basically for comparison purposes. So in part A here, it says, overall, which website received more traffic during the given time frame? And so we would gauge that by looking at, we can see that majority of the time this red curve is always above the blue one, and so the red corresponds to Pop Parade. So Pop Parade would be our answer there. And this is, I should have prefaced this by saying this is the visits to 2 new music sites on the web, and this gives you days on the x-axis and thousands of people over on the y-axis. Part B wants to know which day or days show the least amount of difference between these 2 websites. And so what you're looking at there is that you're looking at the gap between the 2. So with our look, you can really just sort of eyeball this. So we can see that day 7 and 8 is very small. Likewise, day 8 is very small, but day 9 starts to get larger. Okay, and those 2 days look pretty much to be about the same difference between one another. So I would say here, days 7 and 8 show the least amount of difference between the 2 websites. Okay. Now part C wants to know which day then shows the biggest difference in the amount of hits between the 2 websites. And hopefully, then what we'll be looking at is we're still looking at this gap, but we want for it to be the largest point on the graph. And so hopefully you would agree that day 11 has the largest gap between the 2 websites. So our answer there would be day 11. And then in part D, it says calculate the absolute and relative change between day 4 and day 12. For music choice. So music choice is the blue line, the line on the bottom. So day 4 is 20. Day 12 would be 120. And so we would do new minus old divided by old. So for our absolute change, these are your formulas from the last unit, absolute change, new minus old, and so we would just, new is the most recent day, so that'd be day 12, so you would have 120 minus the old, minus 20, so 100 hits. And actually it's not even 100 because remember these are in these are in thousands, so this would be 100,000 hits difference there. Relative change then would be new minus old divided by old times 100. So we know that 120 minus 20 is going to give me 100 divided by 20 times 100. That's going to be 5 times 100, and so that would be 500%. There'll be a 500% difference between day 4 and day 12. Okay? All right, I'm going to scroll on over then to the last page. I think that the bar graph at the top should be fairly straightforward. We'll scoot on down then to the stack plot. And generally in these two sections, this type of graph is, computer keeps doing that. This type of graph is the one that folks usually have not been exposed to before. As I said, it's referred to as a stack plot. It's we're looking at wildlife population of 3 different types of wildlife: bears, dolphins, and whales. So the bears are in blue, dolphins are in the orange, and the gray represents the whales. And then over here on the left-hand y-axis, you're giving the actual number of these animals. So the key to reading a stack plot is that whenever you are trying to figure out, how many of these animals are actually represented at a particular point in time, like for example, for 2018 for bears, for example, I need, well, actually, I won't do bears, we'll do something. The only reason I say I wouldn't do bears is because bears, the reason why whenever you're reading a stack plot, you always have to read the top and the bottom. I'll go ahead and do it just so you kind of see what I'm talking about here. Well, the bottom down here would represent 0 bears. The top of the wedge would represent, to sort of follow this across, I'd say approximately 50. That's a pretty good, it might be a hair over 50. It's pretty good at 50. Okay, so then I would say, okay, well, in 2018, bear population would be at 50. Okay, so with the blue, since it's baseline down here at 0, you can just read the top of the wedge. However, let me erase that. If I were interested in dolphins in the same year, so if I'm interested in dolphins, then dolphins, top and bottom of the wedge are sitting here and here. So we agree, okay, well, the bottom of that wedge is roughly 50 dolphins. Top of that wedge up here, I'd probably say 140. So just a little bit of a guesstimate. So if I want to figure out then how many total dolphins there are between in that particular year, then I'm going to, and these must have been in thousands, 140 minus 50. So 140 minus 50, so that would equal 90. It's not clear here as far as, if we're just talking about, one person, what they observed or anything like that. But nevertheless, this is still a good stack plot in terms of showing you how to compute it. Okay, so just be sure that when you're reading a stack plot, always read the top and the bottom, especially if you're not grounded at 0 down here on the bottom. So the blue for the bears, I could always just read the top of the wedge because I'm always going to be subtracting 0. But for the orange, for the dolphins and the whales, I would need to read the top and the bottom of each wedge to be able to figure out how many of those particular animals were represented. So in part A, it says approximate the bear population in 2022. So here's your 2022, here's your bottom, here's your top. Well, we know that bottom down here is 0. The top would register at approximately, I would just tell you to get yourself a ruler. I know that I did whenever I was doing the homework for this section. Get yourself a ruler, and it's hard for me to kind of come across here, but I'm going to say roughly around about 180. Maybe you say 175. So I say around 180. Okay. Approximate the whale population in 2022. So the whale population in 2022, I would say, is also stopping down here, and then it goes up to here. So we're saying if we approximate this down here at 180. And I would say that one is up there, maybe just above, because here's your 250 line right here, so it's just above that. So maybe 260. You could even go with maybe a 255. Maybe I'll do a 255. So then we would say 255 minus 180. And that would land us at 75. Dolphin population in 2019. So here's your 2019. I've got to read the bottom and the top of that wedge. And you would just, like I've been doing, you'd follow it across on both of those, following it across. So I'd probably keep it there at that 140 minus Let's say 90. These are it would be an approximation. Whenever I would be checking your quizzes and your tests for a stack plot, I would be taking a range. So 140 minus 90 give us approximately 50. Probably any answer between 30 and 60 would be on target there. Okay. Then in part D, it says, according to this graph, what appears to have happened to the dolphin population by the year 2022? According to this graph, you see that orange wedge, and I might need to erase a little bit now, that orange wedge is basically non-existent. So according to this graph, they're saying that dolphins would be extinct. Okay. All right, so that concludes this section. This should be right in line with section 5C and 5D in your Math 143 course. Thanks a lot. Bye.